Hello all, welcome to this online recording sessions in data science. So we have started Python programming, right? So in this session, we are going to see functions concept. Okay, so what is functions? What are different types of functions? Okay, so how functions can be classified, what methods we have in functions, and all those we can see in this lecture. Okay, so coming to different types of functions, as you can see in this slide itself, there are user defined functions, built-in functions, lambda functions, and recursive functions. Okay, so we are going to see in detail about this. Let us talk about functions. Okay, so what is function? So how they came into picture, why these concepts got added into this programming language, so and what got evolved after the functions also we are going to see. So functions, why we need functions, why functions, right? So to perform same task, to perform same task multiple times, to perform same task multiple times, we need a function. Every time, how it will be, imagine you are writing one logic again and again, how it will be, and how will be the case if you write once and again call it when it required. Okay, so the number of lines also gets reduced, and it becomes very clear picture, and the coding part also become very easier if you use functions. Okay, so to perform same task multiple times we need functions. Okay, so earlier, before object oriented programming language evolution also, most of them have used methods and functions. Okay, to write any logic. Okay, to write any logic they used to write in functions itself. But after getting oops concept, after finding the drawbacks in functions and some demerits in functions, then oops concept got evolved. And in oops concept also, there is advantages that functions can be used in that also. Okay, right? So before oops, functions are only the main part. Okay, if you see old languages without oops, they mostly run with the help of functions only. Okay, the languages which don't have object oriented programming. Okay, but when oops came, people started using that. Okay, people started functions also to be used in object oriented programming. Okay, okay, so to perform same task we are using functions, right? Okay, so types of functions, there are different types of functions, like types of functions. Okay, so there are different functions like user defined functions, user defined functions, built-in functions, built-in functions, lambda functions. Okay, then recursive functions. So these are different types of functions. Okay, so user defined functions are the functions that is created by the user. So depending upon his logic, he will design, okay, he will design the functions accordingly. But whereas in built-in functions, we have predefined examples like print, okay, get, post. Okay, so all these are predefined functions. Okay, they perform some task, if you ask. Okay, so they perform some task by default, so that's why we are calling built-in functions. So they are inbuilt, we can use whenever we want. But whereas user defined functions are created by the user to perform the task according the user needs. Okay, according to the problem the user designs. Okay, lambda functions are temporary functions. Okay, so for temporary purpose, for short period of usage, we will use lambda function. It is similar to user defined functions, but here we will write everything in one line. Okay, okay, that is the difference between lambda function. Okay, we need not define every logic in detail, okay, in lambda function. Okay, Recursive functions are those which repeats continuously. Okay, so these are different types of functions. Okay, so now let us see some more concepts related to functions. Okay, so what is the syntax of functions in with respect to Python? Okay, yeah, this is the uh, different syntax of the function. Okay, how you will start a function using a keyword def. Okay, followed by function name, then followed by two colons, then here we will write a logic. Okay, here logic comes. Okay, so function name can be any of it. Okay, you can define any word, except you shouldn't define the keywords. Okay, you shouldn't define any keywords for naming the function name. Okay, that you can keep it in mind. Okay, then you can have parameters also like this. Okay, so here we can define parameters. Okay, and here function name. So it looks like this, the syntax of function. Okay, logic comes or statements. Okay, so here you can see the syntax. Okay, so these are the mainly two types in functions which mostly we will use. Those are built-in functions, user defined functions. Lambda functions and recursive functions are rarely used. Depending upon the situation, we use them. Okay, as a part of the main Python programming language, we use mostly these two types. Okay, yeah, let us talk about some advantages of function. Okay, program development made easy and fast. Okay, so the entire program will become faster and easier. Okay, if you use functions. Okay, testing becomes easy. Okay, if you have a function, we can test it directly. In segment wise we can test. Okay, so we have a block of code and logic in one function and another logic followed by in another function. Okay, so if you want to test, okay, we can go logic wise. Okay, each logic is present in one function, right? So in that way you can call one function and test it. Okay, so coding sharing becomes also possible. So we can share the coding part also easier. Okay, reusability increases. Okay, as functions are there, we can reuse the same function in the entire coding part of ours. Okay, readability increases program readability. Okay, so it becomes crispy. Okay, that means it becomes shortened and it becomes the clear cut rather than having a long programming codes. We have the important logic part. Okay, which makes readability very easy. Okay, function facilitates procedural abstraction. Okay, this is also one of the advantages of the functions. Okay, yeah, so uh, keywords def marks the starting of the function. So these all are the uh, uh, points need to be kept in mind while designing a function. Okay, okay, that most of them we have discussed in the syntax part, right? So we can have return statement also in function. Yeah, so if you take this part, this what it is showing, it is a function because it is starting with keyword def. Okay, then my function name is func. Okay, so then I am having some logic in it, and out of the function also I am having one line of code. Okay, so this is function definition if you ask me. Okay, so function definition. So after defining a function, we need to call it. So if you don't call it, that logic won't get executed. Okay, so in order to execute that particular language, the particular block of code, we need to call the function. Okay, as many times you call the function, as many times that logic gets executed. Okay, so here I am calling the function with function name. Okay, Okay, this is the basic example of how to define a function and how to call a function. Okay, yeah, structure of a function. Okay, how the structure of the functions is categorized means depending upon the parameters and arguments. Okay, so what are parameters? What are arguments? So parameters are the ones that we define in function definition. Function definition. So arguments are the ones that we define during function call. Okay, so I'll give an example. If I have a function like this, def my function 1, okay, x comma y. Okay, so I have a function like this. So print x plus y. Okay, so I have some code like this if you assume. Okay, so here what happens, this is function definition, right? Okay, in order to invoke this function I need to call the function. So how do I call this function? With function name, my function 1. Okay, so in bracket I can give some arguments. Okay, so I can give x is equal to 10, y equal to 20, like this. Okay, okay, so the ones which we are giving, okay, the variables that we are giving in the function call are called as arguments. Okay, the variables that are present in the definition are called parameters. Okay, okay, so that's what we have talked here. Okay, so based upon these parameters and arguments, the structure of function can be classified into 3 categories in respect to Python. Okay, function with no arguments and no return. Okay, so this function can be also called as void function. Okay, because it is having no return type and no arguments. Okay, void function or null function. Okay, function with arguments but no return type. Okay, we have a function but it won't return anything. Okay, function with arguments and return value. Okay, so here I can have instead of print I can have return also. Return x plus y. Return x plus y. Okay, so like this, with return, without return, with argument, without argument, there is a possibility of combinations, and we have we can classify them into 3 categories. Okay, function with no arguments and no return, function with arguments but no return values, function with arguments with return values. Okay, so this we can see live with examples also. Okay, yeah, this is the example for the first one, function with no arguments and no return. So if you see, no parameters, so no arguments. Okay, so no return type also. This is called void function. Okay, so next we have function with parameters but no return value. Okay, we have one parameter but we don't have any return part. Okay, this is second. Okay, second part of the function structure. Okay, next one we have with the parameter with return value. Okay, so you can see here, so we have 2 parameters and return value also. Okay, okay, so returns can be again it can be a variable or it can be an expression also. Return, so in return statement you can use expression or we can use variable also to return that particular item. Okay, so this is the one of the example of using return function. Okay, so if you see, one is a notable point here. So after return statements it won't execute the remaining part of the code. Okay, so return statements ends a function execution even if it is in the middle of a function. Okay, so whenever the return word is there, so it just returns, it won't execute. So it is somewhat similar like a break statement, but there is a difference between break statement and return statement. You need to keep a watch on this. Okay, you can call the parameters as formal arguments also. Okay, parameters. So parameters can be also called as formal arguments. Then we can call what we are defining in function calling, we can call them as actual arguments also. Okay. Okay. So next we have types of arguments. Okay. This we can see there are 4 kinds of arguments. Okay. So first we will see what is function, structure of function, then we'll come back to this. Okay, types of functions based upon the arguments. Okay, so let us move to the practical implementation part. Okay, yeah, so I have taken a new notebook in my collab. Okay, so I'm labeling it as functions.ipynb. So I can use the text file to specify clearly about that program. Okay, functions. Okay, so function is defined with the def keyword and followed by function name my function. Okay, then followed by parenthesis, then 2 colons. Okay, so this is a general syntax. So in this we'll write some logic, okay, inside this function. Okay, print this is my first function creation. Okay, so I am defining some text in it. Okay, okay, if I run it, it will get run. Okay, so first cell, if you take any notebook, the very first cell will take some time to run it. So see, so nothing got executed, even though my print statement is there, nothing is getting executed. Why? Because I have not called that function. So I'm calling the function. Okay, my function. Okay, my function. If you call it, shift enter. Yeah, so whatever there is present in that function, we get an output. Okay, so whatever there is in that function get executed. So in this function I have one print statement, you could see that output here. Okay, yeah, so this is just a basic function, right? So next we will see structure of the function, as we have mentioned. Okay, so the structure we have seen so far is function with no arguments and no return values. Okay, this is one type. Function with argument and no return values. Function with arguments and with return type. Okay, so these are the 3 structures in functions. Okay, function with argument and with return values. Okay, return values or return statement, you can consider it in any way. Function with no arguments and no return values. Okay, so these are the these 3 are the structures of functions. Okay, so one by one let us see it. Okay, so first one, def my function. So here, so I shouldn't use any arguments or any parameters. So this is my, so see, if you see, the advantage of Colab is AI is integrated with this Google Colab. Okay, so whatever the programming part I am writing it, so it is senses. Okay, so it will senses and it reads our program and it will suggest few lines of codes by default. Okay, so if you want, you can use them by pressing tab, or else you can write start continuing your own logic. Okay, so def my function, I will take no arguments, right? So a equal to 10, b equal to 20, b equal to 20, c equal to a plus b. Okay, so then print c is equal to a plus b, right? C is equal to a plus b. Then print addition of a and b is c. Okay, so I'm just writing some logic inside this function with no arguments and no return type. So now what I will do, I'll call this function. So calling the function should be outside the function. Okay, so we need to call by function name, my function. Okay, so my function. Okay, so I'm just running it. So see, so whenever I call the function, so it is going back to the function definition, and that lines of code is getting executed. So it has taken a equal to 10, b equal to 20. It has performed some addition. Okay, so it has performed some addition. Then it is returning one statement, addition of a and b is 30. Okay, so this is how the first structure of the function looks. Okay, you can call this function as void function also, right? So we can call this function as void function also, because it is having no return type and no parameters or arguments. Okay, void function. So we are giving special name to it since it is having nothing. Okay, so now let me take the another code cell and let me run the another structure of the function. Okay, so the very next structure of the function is with arguments but no return values, right? So def my, so see next it is suggesting with arguments. Okay, so it has read this text file, I think, so that's why it is suggesting maybe. Okay, so I'm just pressing tab. So because this is the programming I would like to explain here. Okay, so here you can see with arguments but no return type. Okay, so same code what I have written, it is modifying and it is sharing to me. That means you can see here the AI is reading my entire code. Okay, it will read on your code. Okay, the code which I have written, and it will suggest it within a fraction of seconds, that too. Okay, yeah, so this time I'm taking two parameters. Okay, so while declaring parameters, we need to have same arguments. Okay, so this and this need to be same. So if you're having three parameters, we need to have three arguments also. So these are parameters that we have in function definition. So these are arguments that we have in function calling. Okay, so these two need to be equal, otherwise we will get an error. Okay, so if I execute it, so addition of a and b is 30. So same program with parameters have executed. Okay, so can you can label this, right? Let me label this program as a function with arguments or parameters, you can say, and no return values. Okay, okay, so next, so if you I would like to share one more point also. If we have more or less arguments, okay, so I have said number of parameters should be equal to number of arguments. Okay, So if I give only one argument, if I run it, I'll get an error, okay, type error, okay. So if I give extra also, you get an error, okay. It should be more, it should not be more, it should not be less, it should be equal, okay. Then only we get an error free program, okay. So next, okay, I hope it is clear. So next we will see function with arguments, and return values, okay. Return values or return expression or return parameters, whatever you can call, okay. So def my function to def my function to. So here I will take let me take arguments also, right? So x, y. So now z equal to x plus y. See, now you see my function is getting created with return statement, okay. So with the help of AI, so if you are beginner, you won't get much code experience, okay. If you are experienced and if you want to avoid writing the more number of lines, if you want to take the help of AI, you can continue. But for a beginner, if you are starting a programming in Python, so I suggest you go with IDLE. Then again, after having hands-on practice, come back again and start working in Google Colab, okay. So in that way you can learn flexibly, okay. So return z, okay. So now this is the my function definition. So with the parameters, so with the parameters and with the return type, okay. So now I need to call the function, okay. See, all with the help of IntelliSense only, my entire program is getting created, okay. I can avoid myself typing n number of lines because I'm using Google Colab. Yeah. So see, let me execute it. Yeah. So return z, okay. So return z, we are able to return, okay. So addition of a and b is z, okay. So we can have another function also. So let me write that function for subtraction if possible. Def my function 3. So what my AI is thinking. So it is again, okay, x comma y. So here I want one variable as a equal to x minus. So I'm trying to perform subtraction here, okay. Return a, okay. So I need to call the function, right? Yeah. So let me execute it. So if you see here in this code block, I have defined two functions, okay, my function 2 and my function 3, and I'm asking it to return two returns, and I'm calling two functions, okay. I have defined two functions and I'm having two functions calling. My function 2 is getting called and my function 3 is getting called. But see the output, what output you are getting, okay. So the last one only we are getting the output, okay. So that you need to observe, okay. So now what I will do, if I want to call again my function 2, okay. So now it will return 30. So I need to call separately. If you are not calling separately, what happens? The last statements only it is getting considered. Okay, so otherwise you can run in separate code cell. Okay, you need to create some separate code cell, then you can run it. Function call. Okay, so in one cell you are able to give only one function call. Okay, if you are having many function calls also, it is taking the last function call only by default. Okay, so if I recall with my function 3, what happens? My function 3. Okay, you're getting a C. If you are taking different code cell and calling the function, that's fine. Okay, if you are calling in the same cell, you are not getting it. Okay, so you can remember this. Okay, so these are the different structures of the functions. Okay, so if you see uh, in function call and function call, so the number of arguments and the number of parameters are same. Okay, okay, so now let us come back again and talk about these parameters and arguments. Okay, so what combinations and what types, again the functions categories will be there depending upon this. Okay, okay, so how arguments can be different types. Okay, so let us see the theory part. Okay, so we have 4 types of arguments. Okay, so one is positional arguments. Okay, in positional arguments we have parameters and arguments equal. Okay, so if you are defining parameters like this, my function 1 and x comma y, return z is equal to x plus y. Okay, so then you are calling my function 1. Okay, so now you are giving 10 and 20. Okay, so here what happens, 10 will be assigned to first parameter, 20 will be assigned to second parameter. Okay, so in the chronological order only it gets assigned. Okay, so whatever the values you're giving in function call, so same it will map to the parameters that are there in the function definition. Okay, okay, those are nothing but parameters. Okay, okay, so same positions get assigned to here. Okay, so this is the example for positional arguments. Default arguments, so default arguments, how it looks, def my function to x comma y. Okay, return z equal to x plus y, print z. So if I have a program like this, so now I am calling a function, my function 2. Okay, if I give with only one parameters. Okay, we need to have one default parameter, right? So I'm giving 20 here. So remember here the default arguments need to be present at the last. Okay, so if you're having n number of parameters in function definition, okay, we may have a, b, c, d, e, f, g, like that, so on in parameters in function definition. Okay, instead of just x and y. Okay, so while having like this, the default values which are there, those need to be present at the last. Okay, otherwise you'll get an error. Okay, so it should be at very last. Okay, all the default parameters. Okay, so now in the function call I'm giving one argument. Okay, okay, it should be 2 actually, but since I have an default parameter, I can give 10. Okay, yeah, so now if I run this program again, I'll get an answer as 30. Okay, even though I did not give one argument. Okay, next, keyword arguments. So keyword arguments, it looks like this, def my function 3 x comma y. Okay, return z is equal to x plus y. Okay, print z. Okay, So if the program is like this, keyword argument, right? So y equal to 20. Okay. So y equal to 20 we can take, or we can avoid this also. But since I'm showing keyword argument, so what thing you need to remember in keyword argument? My function 3. Here we will assign x is equal to 10, y equal to 20. So even though if you keep y equal to 20, that's fine. Y equal to 30. If you give here, you see this, will it get override of this y equal to 20? So check it. Okay. So this type of function calling is called as keyword argument. So we will assign here. So what value should be the x, what value should be the y. So we can interchange also. First we can write y, then we can write x. Okay. So if you're not giving like this, what happens? The very first one will get assigned to the first parameter. The very second one will get assigned to the second parameter. If you don't give keyword type. Okay. So if you're giving in keyword type, depending upon this assignment only, irrespective of whatever the arrangement, it get assigned here. Okay. I hope you are getting what I'm trying to share with you all. Okay. Okay. Next, variable length argument. So variable length argument, how it looks? Def my function 4. So every time you see the number of parameters and the number of arguments should be same in case of all, right? So what if I use more or less sometimes? Do I need to check every time? No need, right? So at that time you can keep star mark. Okay, star mark followed by one variable. Okay. Okay. Return z is equal to x plus y. Okay. Print z. Okay. So in function call, you can call like this, my function. So x is equal to 10, y equal to 20, z is equal to 30, a equal to 40. You can give so on, but whatever it is required, that only it will take. So since it is star is mentioned, you can give as many as you can. Okay, as number of arguments as you can. Okay, because you have given star mark. Okay, if you are not giving star mark, no, the number of parameters and the number of arguments should be matched always. Okay, if you don't want, if you want to avoid errors of this type, you need to put star mark and you can give as many as you can. Okay, yeah, you can see this as example. Default parameter, so arbitrary keyword argument. Okay, so we have 4 types, so let us see. So one by one. Okay, so one by one, and again come back again and continue with this function concept. Okay. Okay, so let me open the okay text file. So in this text file, what I will take, arguments. There are 4 different argument types for functions in Python. Okay, so what are they? Okay, what are they? Positional arguments. The other one is keyword argument. The other one is default argument. The other one is variable type. Okay, so variable type argument. Okay, so these are the different 4 types of arguments that we have in functions. Okay, so let us start with the very first one, positional arguments. Okay, def my function. Okay, can I take this example for positional arguments? Yes, right? So I will call this function my function 10 comma 20 is fine, so I'll let it be. So you see positional arguments. In these positional arguments, what happens? 10 gets assigned to A, 20 gets assigned to B. Okay, those positions will be matched. Okay, and it should be equal. Parameters and arguments should be equal. Okay, so addition of A and B is 30. Okay, so this is the example for positional arguments. Okay, so let us label this as positional arguments. Okay, next type what we have, keyword arguments. So in keyword arguments, so in keyword arguments what happens? Def my function. Okay, my function x comma y return so x plus y. See the beauty of the AI. So it itself is only suggesting. So until and unless you are perfect, you cannot trust AI also. So whatever you want to, what is in your mind, what you want to execute. So do you want to really follow AI? It all depends upon you. Okay. So say every time you can't trust AI. You may dealing with one. It is just suggesting. Okay. You may dealing with one. AI is dealing with one. Okay. So it all depends upon you. Okay. You should, until and unless you are somewhat have hands-on experience, you cannot trust AI also. Okay. And you shouldn't take always also. Okay, so depending upon, if it is required only, you can trust AI and you can consider the code. Okay, so here what happens in keyword arguments? So I need to specify the values in the function call. Okay, so here I can interchange also. Okay, y equal to let me give as x here. Okay, so and if I run, see 30 I'm getting. Okay, so the very okay, so this is the example for keyword arguments. So you can give it shouldn't be the very first argument need not be x value, the very second argument need not be y value. Okay, so you can predefine it here, what is x value, what is y value, and all we can define it in the arguments in this case here. Okay, so this is example for keyword argument. Okay, so so if you don't define like this, the very first argument will be matched to the very first parameter. Okay, if you're not giving in the form of keyword. If you're giving in the form of keyword, that's fine. Okay, so next one, default arguments. Okay, so I will take code cell def my function. So in my function, so here I will give x and y, y, and z also I'll take this time, z equal to 10. Okay, so the default argument should be present at the last. So you can have any number of parameters in the function definition. Okay, but all the default value should be in at the end. Okay, so a equal to 20. So I'm having two defaults. Okay, so addition of what 4 numbers. Okay, so let me consider this only what AI is considering. So and see. Okay, so if you see here, now what happens in function call? So this is my logic, this is my function with 2 default arguments. Okay, and this is my logic in this function. So in function call, you tell me how many parameters I need to assign. There are 4. Okay, and 2 default. Okay, so I need to declare 2 arguments in the function call. Okay, So if I running it, see, it is giving 60, 10 plus 20 plus 10 plus 20. Okay, x is 10, y is 20, 30, 40, 60. Okay, so if you interchange this, okay, so if you give x is equal to 10, okay, x is equal to 10, will it run? See, no non-default arguments follows default arguments, so it is not supporting. Okay, see, okay, we have seen practical also. So that's why we need to put default arguments at the end. Okay, next, if you have, if I declare z value also, z equal to, I already have default value as 10, but if I define 40, what happens in this case? Is it getting overridden? Okay, is it getting overridden? Check it. So x is 10, 10 plus 20, 30, 30, a value is 20, 50 and 40. Okay, so this is getting overwritten. So even though you have default parameters in the arguments, you can give it even though there are default arguments. So what I'm doing, again I'm redefining the z value here even though it is here. So at that time what is happening, this new one is considered. Okay, so always mostly in programming part, the new ones will be replaced with the old ones, whether it is a function name or whether it's a variable name also. Okay, this is the example for default arguments. Okay, so here you need to remember the default argument should be at the end. Okay, so the next type of arguments, okay, variable type. Okay, variable type arguments. Okay, okay, or you can call it as quarks. Okay, so here what happens, every time it shouldn't be matching. Okay, okay, every time it shouldn't be matching. So what if I give here, there are 4 variables, right? In function function definition there are 4 variables, right? So what if I give 5 parameters here? I'll get an error definitely, right? So I'll give a equal to 50 and then followed by 10. Then let us see, here 5, here 4, what happens? Yeah, error. So even though you are using default parameters, you need to see matching. Those number of parameters need to be equal to the number of arguments, even though you have default parameters. Okay, if you remove this, now it will be fine. There are 5 parameters and 5 arguments is fine. Okay, it should be equal always. But in case of quarks, what is the advantage here? It shouldn't be equal. Okay, you see, def my function x comma y. Okay, so here what I will do, see, my AI is suggesting. So you can consider the what AI is suggesting also. It is suggesting x and y and then followed by star. That means x and y will be there. In continuation to that, I have quarks. That means I have n number of parameters. Okay, apart from x and y. Okay, you can remove this also. You can remove this. You can remove this and simply put like this also. Okay, my function got an unexpected keyword argument a. Okay, so you don't define like this, a equal to like this, because again it will check in quarks. Okay, so this time, so I need to change my program. So let me take another program. Okay, def my function, and then you can take this. Okay, you can take this, or else you can take the other one. You can define manually on your own. Okay, so that's why this time I'm not trusting my AI. Okay, params. So you can define one variable after star mark. Okay, so here what I will do for in params. So let me consider this program. Okay, so here what will happen? So for in params, print I. Okay, so I will print I. Okay, 10, 20, 30, 40, 50. Okay, so I am giving as many parameters as I can in the function call. Okay, then I am writing some logic to be executed here. Okay, so you see here, so the number of parameters and the number of arguments are not equal. So in order to avoid this contradiction, I am just declaring as star followed by one variable. Okay, params is a variable. So this type of function is called as function with quarks, or function with variable type arguments. You can call like that also. Okay, I hope it is clear. Okay, so next part we will see. Yeah, you can call formal arguments as the parameters, actual arguments as arguments. You can call with different names also like this. Yeah, next comes the scope of a variable. Okay, in scope of a variable, what is there? If you define a variable inside a function, okay, and if you're defining a variable, okay, same variable outside the function, what happens in that case? See, so you're defining one variable inside a function and same variable outside the function. So if I'm printing x, what is happening? You're getting two different outputs. Okay, so if you, in order to avoid this, you can declare global variable. Okay, so if you're declaring global variable, so that means that variable will function same inside the function as well as outside the function also, it looks same. Okay, so let us see this and let us take this as a last topic in this function. Okay, if at all there, we'll continue in next session. Okay, so next I will talk about global variables, scope of a variables in functions. Okay, scope of a variables in functions. So here what happens? Def my function x comma y. So x comma y, so I have not completed. So x comma y, so okay, let me take this program. It's look fine, there is no error in it, I can take it. So scope of a variable. Okay, so let me give print a, that's fine. So outside the function, if I define outside the function x is equal to, sorry, let me change this program, entire program. A equal to 10, b equal to 20, c equal to a plus b, print addition of, okay, this is fine. I'll take this program, addition of a and b is fine. Okay, okay, so now if I give the variable again, so if I define the same variable what is present in my function again, so a equal to 5, so what is happening? Print a, let us see again what is happening here. I'm not getting an a that is defined here. So I'm getting an A. So let me take this. Okay. Let me delete this also. I don't need. Okay. Now you see here. So I'm asking it to print A. I'm asking it to print A. Okay. So what is happening here? So A value I have given 10. Okay. So A value I am given 5. So every time if I am calling function, it is getting overridden. Okay. So, but what if I given with global A. Okay. Global A. So A equal to 10. No, global A. Okay. 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 Global A. So what happens in this case? So 35. Let me give this as small a. So see here, if I give global for this variable, so what is happening here? Even though I am defining a equal to 5 outside the function, but it's printing 30 only. Why? Because I have declared a as a global. That means whatever it is assigned to a in the beginning, that will be only considered if you call as many times as you. So inside the function or outside the function, if you call as many times as you, it will be print the value that is assigned with the very first time. Okay. So first time I have assigned the value as 30, because 10 plus 20 is 30, right? So 30 is got assigned to a. So every time I'm asking it to print a means it will print 30 only. Okay. If you type again print a, what happens? Again 30 only. Okay. So this is the advantage of global. Okay. So global a. This, now you can call this variable as global variable, and this variable as local variable, b as local variable. Okay. This is local variable, that is specific, that is scope, that variable scope is inside that function only. Okay. That's why we call that variable as local variable. Okay. So now whereas this variable is global variable, okay, global variable and local variable. So I hope you understood this concept also. Okay. So this is all about the functions concepts. Okay. So in functions you can use if else functions also. You can see lists, tuple, set, dictionaries also, and you can work on them also in functions, how it is responding. Okay. So if you all try all this hit and trials, so what is happening, in that way you can learn very much about functions. Okay. So I hope it is clear now. Okay. So thank you all. So thank you for giving this opportunity. Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.